In this video, we're going to be talking about how two lines are parallel, intersecting, perpendicular, or skew. Here we're given two lines, L sub 1 and L sub 2. Both of these lines have three parametric equations associated with them. L sub 1 has a parameter value of t, whereas L sub 2 has a parameter value of s. Well, how are we going to test whether these lines are parallel, intersecting, or skew? Well, here are some basic steps in order to do so. First, you can test if the line is parallel. If the line is not parallel, then you can test if the line is intersecting. And if the line is not intersecting, then it must be that the lines are skew. Any two lines must fall into one of these three categories. In order to, if a line is perpendicular, it's an offset of it being intersecting, because if two lines are intersecting, they may or may not have an intersection angle of 90 degrees. First, we're going to be testing if the lines are parallel. So in order to test if the lines are parallel, you must take the coefficient on the parameter or direction number and make a ratio, and set each of the ratios equal to each other. If this equation holds true, that means that the lines are parallel. So for the x parameters, we get 2 and 4. So you make a ratio 2 over 4. For the y parameters, we get -1. You have to take care of the negative there. It's negative t. So you get -1 and -2. So you get -1 over -2. And finally, for the z parameter, you get 3 over 5. So that's that. And when you simplify each of these terms, they turn out to 1 over 2 and 1 over 2, but the final one does not simplify to 1 over 2. Therefore, these lines are not parallel. The next step is to test whether the two lines are intersecting. In order to test for intersection, you must solve a system of simultaneous equations. In order to do this, you must set the x parameters equal to each other, you must set the y parameters equal to each other, and you must set the z parameters equal to each other. So here we have done so. We have 3 plus 2t equals 1 plus 4s as the x parameters. You have 4 minus t equals 3 minus 2s as the y parameters, and 1 plus 3t equals 4 plus 5s as the z parameters. Now, in order to start solving them, you can start off with the x parameters. So we've isolated for t in the x parameter, and we get 2t equals 4s minus 2. And if you divide both sides by 2, you get t equals 2s minus 1. So we've isolated for the t term in the x parameter. Now if we sub this 2s minus 1 as t for the y parameter, we get 4 minus, and in the t section you sub in 2s minus 1 equals 3 minus 2s. Now if you simplify this and you bring the 2s over to the other side, the s's cancel out, so you get 0, and if you bring this 3 over to this side, you get 4 minus 1 plus 3, which is 2, and 2 does not equal 0, so we know that there's a fault in the system of equations we're trying to solve. So we can conclude that these lines are not intersecting. However, if you did end up with a value for s that made this equation true, you can plug that back into here and see if these two are equal to each other. And if they are equal to each other, you have a system of intersecting lines. However, we do not have to go this far because we have already found a fault in the system. Now, since these lines are not parallel or intersecting, we can automatically conclude that these lines are skew. Finally, here's an extra step to check whether the lines are perpendicular or not. In order to check that the lines are perpendicular, you must take the dot product of both lines, and if the dot product equals 0, then the lines are perpendicular and they are intersecting at an angle of 90 degrees. In this case, the lines aren't intersecting, so they will not be perpendicular, but we'll go through just for demonstrational purposes. So when taking the dot product, you must have the sum of the products of all the direction numbers. So that is 2 times 4 plus -1 times -2 plus 3 times 5. This equates to 25, which is not equal to 0, and thus this is not perpendicular. Thanks for watching. I hope you're able to test for whether lines are parallel, intersecting, skew, and perpendicular.